Hello guys, welcome back, and I have here with me a beautiful problem. The problem was given to me by a student of our batch. So the problem is the following. The problem says that if, like, let's say you have X balls of red color, identical, Y balls of blue color, and Z balls of green color. So X plus Y plus total balls are 30. The question is that if you want to arrange these balls into, yeah, they're not in a row, in 30 places are there, how many ways are possible, right? That's the question. You know, it's very easy. How many ways are possible? You first choose the X places for this identical red balls. So 30 choose X. And among the rest 30 minus X places, you choose the Y places for the blue balls. 30 minus X choose Y, and automatically it will fix the plus for Z balls because it's 30 minus X minus Y times Z, and X plus Y is equal to 30 minus Z, so therefore it turns out to be 1. So therefore total number of ways you can actually uh, place these balls or arrange these balls in 30 places. In this 30 balls in 30 places in a row is this, which if you just write it down properly, you get 30 factorial by X factorial times 30 minus X factorial. From here, the 30 minus X factorial is coming up, and here it's Y factorial and 30 minus, so it's Z factorial, okay? So this gets cancelled. So finally we get f of xy is nothing but 30 factorial plus by divided by X factorial by Y factorial till 30 minus X minus Y factorial. If you want to try to find a function, in terms of functional form. So let me write it down, properly for it. Yes. So if you want to write in a forms of functional form, you can see that. Just give me a minute. Yes. So therefore we get that, for X, so this is a function we are getting, and X, Y are integers from 30 to 0. Okay. So the question is that for which X Y pair f of xy is maximized. Now, if you remember, if you know the binomial thing, the same case, if you remember the binomial thing, the binomial says that, let's say in factorial, let's say it was 30 factorial by X factorial times 30 minus X factorial. The binomial theorem says, or in fact, the binomial way says that this will be maximized as X is equal to 15. Okay, this is pretty easy to prove. So what was the method in that? We assume this was f of x, and we did this f of x plus 1 by fx, okay, greater than equal to 1, less than equal to 1. This was if and only if we found out that, so it's a discrete version of for sure its derivative, okay? We're trying to understand what point it's increasing, okay? Because f of x is equal to f of 30 minus x. It's the same thing, it's symmetric. So we're trying to understand till which point it's decreasing and then it's increasing and then it's decreasing again. So therefore we did this and we found out that, yes, let me find out. So we found out that x plus 1 by 30 minus x is greater than equal to 1, which is nothing but equivalent to saying that, oh, I did a mistake, I guess. So it'll be 30 minus x by x plus 1. And we have got here, I guess, 29 greater than equal to twice x. So we can find out from here, in fact, we can find out that therefore the minimum will happen either at, if you understand it carefully, either at x is equal to, so you can understand minimum will either happen at 28 or 30. So it's 14 or 15, that 2x is equal to 30 or 2x is equal to 28, because it should be divisible, right? So, and if we, put the values, we find out that x equal to 15 makes maximize. This was the proof of it. So we'll just extend this proof idea. We'll extend this proof idea to here, okay? The two-dimensional one. You should actually be able to extend this and prove this in multiple dimensions, okay, for n k variables. So f of xy, the f of xy is equal to 30 factorial by x factorial times y factorial times 30 minus x minus y factorial, right? This was the whole thing. And we got that so let's say, so what we will do, we will do it in two cases. Like for two-dimensional functions, we did what? For two-dimensional functions, we usually did partial derivative, right? For two-dimensional functions, we usually did partial derivatives. So we will do the equivalent of partial derivatives. Okay. So how to do the equivalent of partial derivative? We do the equivalent of partial derivative. What we do? We do f of x plus 1. We fix x, y, and do this. And if we do this greater than or equal to 1, same thing, we get that it's equivalent to, just by doing some computation, you will see it's equivalent to saying that 30 minus x minus y by x plus 1 is greater than or equal to 1, which is equivalent to, again, 29 is greater than or equal to this, twice x plus y. Similarly, since it's symmetric, what you can also say is the following, that f of x, now we do the partial derivative with respect to, the discrete partial derivative. We are trying to understand, giving x constant, when it will be the maximum. We will see similarly that it will be 30 minus x minus y by y plus 1. And it's equivalent to saying that 29, this is x plus twice y. So these are the two conditions we get. Now understand, let's assume that since it's a finite number of terms, so of course the maximum must exist. Let's assume that x star, y star is the maximum, where the maximum of fxy is happening. It's taking the value. It can be many values, but let's take that it's one of them. So therefore, understand, therefore the maximum must, so since 2x plus y, therefore the maximum will either take, so therefore the maximum must happen either at 2x plus y is equal to 28, just before that point, because it may not be that exact point, right? Just at that point or just after that point, 30. Because it may not happen exact, 2x plus y may not be 29, it may just be 28 or 30, just one below or one after. Similarly, like this. It may either take 30 or it may either take 28. So therefore, observe that the maximum must, satisfy both of this, right? Now, one of them must happen. So we have what? So therefore, we have that 2x star plus y star must either be 28, 29, or 30. Similarly, x star plus 2y star must either be 28, 29, or 30. If we add this two, what are the possibilities we get? If we add this two, what the possibilities we get are what? 3x star plus 3y star must either be 28 plus 20, 56, 57, 58, 59, or 30, or 60, sorry, when both of them are 30. Observe that therefore this right hand side was divisible by 2. So therefore we have two options, either 57 or 60, right? Others are not possible. So therefore we get the maximum, the x star plus y star must either be 57 by 3, that is 19, or 20. The maximum must satisfy this. Now observe one thing very carefully. Let's get back. So let's take this case. So let's take the case when, let's call the value this when x star y star is equal to, when x star plus y star is equal to 19. Let's say the value of f of x is lambda 1. X star y star is lambda 1. For that we get that it's 30 by x star 19, sorry, x star factorial into 19 minus x star factorial times there is 11 factorial. And lambda 2 के लिए, where f of x star y star, when x star plus y star is equal to 20, the second case. For that case, this let's take this takes the values this x star factorial times 20 minus x star factorial times 10 factorial, right? Now observe that this takes the maximum value. Also observe this. Let's see when this is greater than this. So let's take lambda 2. Let's assume that lambda 2 is greater than lambda 1. Let's see when it happens. So lambda 2 is greater than lambda 1 if we just divide this by this. So we get, let's see, we get 11 by 20 minus x is greater than 1, which is if and only if x is less than 9, is greater than 9. Let me check. Yes, x is greater than 9. So if x is greater than 9, therefore lambda 2 must be greater than lambda 1. Now let's see when this happens, that for lambda 2 when it varies over x star can take values now what? Till 0 to 20, right? When it varies over x star, by the binomial thing, we know that it takes the maximum value, right? When? Because lambda 2 is nothing but 20 choose x star times 30 choose 20. So there's a constant. So therefore, lambda 2 takes values maximum. So lambda 2 ka max value happens when x star is equal to 10. So lambda 2 max happens when x star is equal to 10. And therefore, lambda 2 max when x star is equal to 10 must be greater than the same value of lambda 1 when x star is equal to 10, because lambda 2 is greater than lambda 1 when x is greater than 9. So therefore, among lambda 2, so therefore, lambda 2 max, that is when x star is equal to 10, is greater than all lambda 1 when x star is equal to 10. Is greater than 10. Right? So therefore, we get what? We get that the maximum value where lambda 2 happens maximum value where lambda 2 takes is always greater than equal to, for x star greater than equal to 10, it always, x star greater than equal to 10, always that surpasses the lambda 1. Now the question is that, what happens if x is less than that? So let's see, is less than equal to 9. So understand this very carefully, that lambda 1, if you remember, lambda 1 is a function of x star. Now remember that. It's nothing but 30 choose 19 into the other one is 19 choose x star. The function of x star, remember. And lambda 2 x star, nothing but 30 choose 90, 30 choose 20 into 20 choose x star. Now magically, you can understand that lambda 1 ka max happens at x is equal to x star is equal to 10, right? Or 11, which is like 10 or 9. Why? Because you can understand it's the middle of that. So it's 10 or x star is equal to 9. So both the values are same. And the max of lambda 2 happens at x star is equal to 10 again. So therefore, both ka maximum happens at x star is equal to 10. Right? Right? And this is what you get. And therefore you get that, at this x star is equal to 10, lambda 2 is greater than lambda 1 because x is greater than 9. So the maximum of lambda 2 at x, or the function of x, is more than maximum of lambda 1 x is equal to x star, where the maximum is happening. So the maximum of both the function is maximized at x star equal to 10. And hence, the maximum value it can take is at x star is equal to 10. And the maximum value happens at x star is equal to 10. You can check that. So therefore, what do we get? We get that f of xy. So if x star, y star, the maximum exists, so therefore the x star must be equal to 10. And x star plus y star must be equal to 20, so y star must be equal to 10. Because x star is equal to 10. So the maximum value that happens is x star comma y star is equal to 10 comma 10. You can generalize this method by induction to for k number of variables. That is, when does, like, let's say n factorial by n1 factorial, n2 factorial, dot nk factorial is maximized by summation of n I from 1 to k is capital N. You can also find the maximum of that. That's really interesting. So therefore, using this discrete partial derivative method, you can actually find out when it's actually the maximum is happening, guys. It was a beautiful problem. I really loved it. I hope you enjoyed it too. For more such videos, stay tuned to this channel. And if you like this video, do share, subscribe. And if you have some different way of approaching this problem, because it can be generalized to beta integral and stuff. So try out this food for thought problem and try and share in the comments with your uploading your file in a drive, your work, that how you can do it differently. Okay. I hope you enjoyed. I will see you in the next video. Stay tuned and stay blessed. And don't forget to subscribe, share, like, and that can support us, that can support and help us can make such beautiful videos for you. Thank you guys, and I will see you in the next video. Stay tuned and stay blessed. Bye-bye.